Our first new technique of integration is something called integration by parts, which is not a great name for it. It would really be called doing the product rule backwards. So here's how it works. If I'm trying to find the integral of x times cosine of x, rather than think of that directly, I want to think of this in terms of a derivative problem. Could I have a product rule problem where when I take the derivative of a product, one of the two terms that comes up from the product rule is x times cosine of x? And the answer is yes, we can if we think about it. So here's how it would work. And we'll talk about how I can figure out what these values are in a minute. But suppose I'm trying to find the derivative of x times sine of x using the product rule. The derivative of x times sine of x is going to be the first of those things, x, times the derivative of sine, plus the derivative of x, which is 1, times sine. So that's what the product rule tells us is going to happen when we take the derivative of x times sine of x. Notice that one of the two terms that I got from the product rule is exactly the thing that I'm trying to integrate. So that's the key. Can you imagine a product rule problem? So when you take the derivative of a product, one of the two terms that you get is exactly the thing you're trying to integrate. If that happens, then you can do this. If these things are equal, then taking the antiderivative of each side should also be equal. And if you're really paying attention, you'll tell me that they don't necessarily have to be equal. They have to be within a constant of integration, which is certainly true. And we're just going to hold on to the idea that there should be a constant of integration somewhere, because all three of these integrals will have their own constants of integration. And so that's three different numbers that can come up. And so we can just wait till the end and resolve that. So we don't want to forget that, but we don't need to deal with it yet. So this has to be true. On the left-hand side, the derivative of something prime, well, that's just saying take the antiderivative of the derivative of something. And so that's a wash. So x, the antiderivative of the derivative of x sine x is just x sine x. So that's going to happen on the left-hand side. And again, it would have a plus c, but we'll hold on to that for the end, is equal to this integral, the thing I don't know, plus the integral of sine of x. Well, the integral of sine of x is, again, something that I know. In this case, I have to actually know some of my derivative rules, but the antiderivative of sine of x is negative cosine x. And again, plus a constant, but we'll wait till the end for that. So finally, all I need to know is this piece. And so because these things are equal, I'll just add I'll add cosine of x to both sides of this equation, and it'll tell me that x sine of x plus cosine of x is equal to the integral of x times cosine x dx. So I'm all the way to the end for my answer. So here I'll put the plus c that I know was lurking all along. I'll put it in my final answer. But this is the antiderivative of x times cosine x. We can trace these steps to come up with the rule that you'll see written in a box that's called integration by parts by just thinking about what's happening in general here. So in general, I'll have a product rule that starts with some u times v, and we know that the product rule says this is uv prime plus u prime v. So the product rule says that. So I would be in a situation where one of those two things is the thing that I'm trying to integrate. So let's say it's that one. So from the product rule, I'll then take antiderivatives, the integral of both sides. And again, that integral here, we consider that the question that we're trying to solve. And so finally, I'm going to subtract from both sides the integral of u prime v, the thing over here. I'm going to subtract that from both sides of the equation. And I'm going to acknowledge that this is that the integration and derivative here will cancel each other out. This is the antiderivative of the derivative of uv. So on the left side, I'll have just uv left. From that, I'll have the integral of u prime v dx coming over from the other side, and that's going to be equal to the integral of uv prime dx. Again, this is the question. So this statement is what you'll see referred to as integration by parts. And so what we really need to talk about is this format is very simple. This formula is very simple. But the question is, for a given integration problem, how can you figure out what the u and the v should be so that this, not only does this rule apply, but that this rule actually makes the problem easy to do. You'll notice that all that really is happening here is when we have an integral to solve, integration by parts just gives us another integral to solve. So not every choice of u and v will actually make your problem easier, but that's not really different from what happened with substitution. Remember, when we did u substitution, that also just changed an integration problem into another integration problem. It's perfectly possible to do a substitution that makes the new integral harder to do than the original. So it requires practice to know what the u and the v should be so that the integration by parts is applicable and that it will actually help. In other words, that it will actually give you an easier integral to do to finish the problem. And that's what we'll be talking about in this section.